Hi students, here we have a slightly different question. See the question here. A battery of 9 volt is connected in series with resistors of 0.2 ohm, zero point 0.3 ohm, 0.4 ohm, zero point 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? So here we know that when resistors are connected in series, the current flowing will be same because there is only one path for the current to flow through the circuit. So it will be the same for all the resistors. So the question is only just to check your concept level that in series the current flowing through all the resistors will be same. And this question is taken from your textbook, that is NCERT 10th standard textbook, question number 9 in the lesson of electricity. After watching the video, you try to solve the same question in your notebook also. Okay. Now, for finding the current in the circuit or the current flowing through 12 ohm resistor, first of all we need the total resistance of the circuit. So here we have 1, 2, 3, 4, 5 resistors connected in series. So I am naming them as the first resistor R1 equals 0.2 ohm, R2 equals 0.3 ohm, R3 equals 0.4 ohm, R4 equals 0.5 ohm, and the last one, the fifth resistor, is equal to 12 ohm. Since all these are connected in series, the total resistance of the combination, the equivalent resistance of the combination, will be equal to R1 plus R2 plus R3 plus R4 plus R5. Okay, so on substituting the values of each resistor, the effective resistance will be 0.2 plus 0.3 ohm plus 0.4 ohm plus 0.5 ohm and the last 12 ohm. When we add all this together, the total resistance, it will come 13.4 ohm. 13.4 ohm is the total resistance in the circuit, and we have here the potential is given 9 volt, so we can find the current in the circuit, that is from the Ohm's law equation, I equals V upon R, that is equal to, we have 9 volt here, the battery voltage, divided by total resistance is 13.4 ohm. Now we can find the value of the current here. So we have the voltage here 9 volt, that divided by 13.4 is equal to 0.67164. We'll round off this value of the current as is equal to current is equal to 0.6716, 0.6716 ampere is the current flowing through the circuit. So the same will be the current flowing through the 12 ohm resistor and all other resistors, since they are connected in series. Now we can think about a slightly different question here. Suppose this parallel to the 12 ohm resistor, I am connecting one more resistor like this. Suppose it is 6 ohm. Then the current flowing through 12 ohm will be different. Now we can see here how to calculate the current flowing through the 12 ohm resistor after connecting a 6 ohm parallel to that. So for that, first of all, we need to get the potential difference between these 2 points A and B. Now the voltage between these 2 points we can obtain from the total resistance of these two in parallel combination. So if the resistors are connected in parallel combination, if two resistors are connected in parallel, you know that the equivalent resistance will be equal to the R1 into R2, that is we have 12 ohm into 6 ohm divided by R1 plus R2, that is 12 plus 6. Since it is in parallel combination, the equivalent resistance is given by the equation 1 by R equivalent equals to 1 by R1 plus 1 by R2. By taking LCM and taking the reciprocal, we will get this equation, that is R1 into R2 divided by R1 plus R2 will be the total resistance of this combination, and that is equal to 4 ohm. It will come 4 ohm. So that now we can find the potential difference between these 2 points A and B. This total resistance is 4 ohm, and for that total current will be the same, 0.6716. So the voltage between the 2 points, between the point A and B, the voltage will be equal to the current reaching at this junction is the same main current here, that is 0.6716, 0.6716 into the resistance, that is 4 ohm. So when we multiply this, we will get a voltage of 2.6864, 2.6864, 2.6864 is the voltage coming between the 2 point A and B. So that for that we have used the equation here. The equation used is V is equal to I into R. So in this equation, the current I, we took the same current reaching at this junction, that is 0.6716 ampere, and the resistance we have taken the total resistance of these two in parallel combination, that we got 4 ohm. So that the voltage between A and B is 2.6864, means out of the 9 volt applied here, 2.6864 volt is dropped between A and B. Now we can find out the current passing through 12 ohm, that is I is equal to, equation is I is equal to V divided by R. So here we have to take the voltage, only the voltage coming between these 2 point A and B, not the 9 volt. Okay, that is the main concept you have to understand in this numerical. We cannot use the 9 volt here because this voltage is dropped across different resistors, and between these two combination it is coming only 2.6864 volt is the voltage coming between the 2 point A and B. And only that voltage we have to apply here for finding the current through the 12 ohm resistor. So the current through the 12 ohm resistor is I is equal to V by R, that is 2.6864 divided by 12 ohm. That will give a current of 0.22387. This is giving a current of 0.22387 is the current flowing through, that much ampere is the current flowing through the 12 ohm resistor. Before it was same 0.6716, but now after connecting 6 ohm resistor in parallel, some of the current is bypassed through this one and the remaining is flowing through this one. But if you add the current in these two, total will be the same current here, 0.6716. That we can check once again. So if we find the current flowing through the resistor 6 ohm also, that current also we can obtain as I is equal to V by R. Here also V will be the same for these two resistors. The voltage coming between the 2 point is same, that is in 2.6864. So in parallel combination, you know that voltage will be same, only current will be different, 6864. That is divided by resistance, that is 6 ohm resistance, so that the current become 0.4477, 0.4477. This much ampere is the current flowing through 6 ohm resistor. So one more idea we can get from here: when two resistors are in parallel, the two resistors are getting the same potential difference, same voltage, but current is different. This 12 ohm is getting a current of 0.22387 ampere, and this 6 ohm resistor is getting 0.4477 ampere, and this current through the 6 ohm is greater than that of 12 ohm, because when resistance increase, current will decrease. Now when we add these two, 0.22387 and 0.4477, it is equal to the total current that already we obtained, 0.6716. Means the two current in the two branches added up, and it will give the same main current in the circuit. So here the main concept in this numerical is about this current flowing through the different branches in parallel combination. So if you are getting a numerical like this, to find the current through any branch, first of all we need to find the potential difference between the 2 points of that branch, and that voltage potential difference only we have to apply in the equation of I equal to V by R for getting the current flowing through each branch. Okay, so try this video once again in your notebook and practice it maximum time, so that you must be thorough with this question. Okay, thank you.